Hello everyone, welcome back to another video. Today I'm going to be doing something I don't usually do, which is looking in detail at a past significant weather event. And today we're going to be looking at the catastrophic flooding across parts of the eastern United States caused by Hurricane Helene. Starting off by looking at Hurricane Helene itself and its track, you can see it originated in the Caribbean and strengthened as it moved through the Gulf of Mexico, where it eventually became a Category 4 hurricane with winds of around 140 miles an hour before it made landfall along the Gulf Coast. And in particular, it brought some pretty severe wind and storm surge issues to parts of the Big Bend. But it was really as it quickly moved inland that it dropped a lot of rainfall, particularly in this region here, which caused some, as I said, extreme flooding, really destructive, some terrible kind of footage coming out, which we can look at now actually. Let me just get the tweet. Yeah, so this is some footage. If you just search up kind of Hurricane Helene or North Carolina on Twitter, this is the kind of thing you can see. This is an entire town which has been completely destroyed, which is pretty horrific really. So much debris, those are people's kind of livelihoods ruined, and you can really just get an idea of how bad it was. Complete roads, communities gone. This used to be a road, and you can see now it's just become a kind of washed out road turned into a river. So genuinely catastrophic impacts, as can be seen here in these photos. I'll put all the links to these tweets and this website in the description so you can have a look for yourself. This is really kind of giving you an idea of the scale of this destruction. Really nothing we ever really see in the UK, and really a once in a 1,000-year event for some of these locations. If we kind of get an idea of how the forecast developed, we can look at the Weather Prediction Centre's outlook for excessive rainfall for the day before. And you can see, or actually this is the day off on Friday, the 27th of September, and you can really see we have this long tongue of pink. That's where the highest risk is. That's the highest you can go on the scale, with a 70% plus risk of flash flooding within 25 miles of a point. And you can see extended along Helene's track through Florida, parts of Alabama, Georgia, and then into the Western Carolinas. And so we did know this area was going to be at risk, but probably not quite as hard hit as it actually was. Now, in terms of the kind of rainfall totals, this is a graphic from the Weather Prediction Center, and you can see here the kind of regions and rainfall totals we saw in a bit more detail. Let me change the colour of this pen to black. You can see a lot of rain across a large region. Let me increase the size of that pen because you cannot see it very well. You can see a lot of rain fell over a large region, but the focus was in this dark red and orange across parts of North Carolina, South Carolina, and into Georgia. And the totals we have are pretty exceptional. These are the kind of totals across the whole event, and you can see as much as 30 inches of rain across North Carolina, across parts of the mountains, even widely more than a foot of rain. So this is for the non-Americans 300 to 600 millimeters. So a really, really insane amount of rain falling, and there's no surprise the flooding occurred as severely as it did. In terms of kind of how this developed, I'll first run through the satellite loop, and you can see there is Helene moving through the Gulf of Mexico and then making landfall. But notice what's kind of going on ahead of it. We have this huge ribbon of cloud extending across parts of the eastern US, and then Helene itself moves inland. And actually, it was a large part of the disruption was because of this band sitting ahead of it, and that's actually to do with the upper level pattern and a few other factors which really came together to bring long duration heavy rainfall. We can get an idea of why by looking at the upper level wind chart. So this is Helene here. This is the GFS model. So this is not a kind of a reanalysis. This was a forecast for around kind of Thursday or Friday, just as the storm was making landfall on the 27th. And you can see this area of kind of white is where Helene roughly is. The center at the surface is more like here. But take a note of this kind of upper level low pressure system, which had a kind of zone of strong winds and upper level jet extending ahead of Helene. And what actually this allowed is divergence ahead of the storm, and divergence creates upper level motion because the air at the surface kind of rises to fill the gap. And as you get rising air all through this region, we saw clouds forming and precipitation developing, as can be seen in this satellite loop. And also as part of that, we saw a kind of a stationary frontal zone set up along the kind of middle of that kind of area of upper level divergence, and that helped to develop storms even 2 days before on the 25th and 26th that lasted all the way through to the landfall. And there's actually a specific name for this kind of event, and that is, let me just find the right, here we go. That is called a predecessor rain event ahead of tropical cyclones. I'll put this paper in the description, but you can kind of get a more detailed meteorological understanding by looking at this. This is not specifically for Helene, in case you're wondering. This is from a different case study, I think for 2007 it looks like. But this gives you a rough kind of conceptual model of how things may evolve, and that is where you get a upper level jet to kind of the north or northwest. As you can see here, the rain event took place in this kind of zone here, and there's our upper level jet. And that can create, as I mentioned, divergence, up-level motion, which can allow those clouds and storms to develop. And then also notice we have the mountain axes in orange here. And we did also have mountains in this case as well, the southern Appalachian Mountains, as you can see, extending all the way from the kind of northeast down into northern Georgia. And really the focus was across kind of this side of the mountains here, which lines up with the Weather Prediction Center's outlook, which you can see there. And now the reason for this is because Helene and general kind of tropical cyclones in general brought a very, very large amount of moisture. All in purple is indicating where the kind of air is completely saturated. There's a lot of moisture in the air, and so any rain that does fall will be heavy and typically kind of prolonged and damaging. And you can see the kind of worst of this in the purple and the kind of white really pushed north. If we move through, we change the intervals on this, really pushed forth during the early hours of the 27th as Helene kind of made landfall. And you can see the way it kind of moves up. Let me just continue to run through this. Yeah, you can see the way, I skipped too far I think. You can see the way it pushes in and kind of stays quite stationary across kind of northern Georgia into the Carolinas in this sort of region in red. And also notice how, because of the upper level jet, this moisture was already being pulled ahead of the storm, so that really we had this entire tongue of lift combining with the moisture leading to heavy rainfall. And also where we have that moisture already in the air, where it runs up into the mountains, that air rises, it's forced to rise due to the topography, it cools, it condenses, forming rain clouds, and then continuous heavy rain. So similar process to how we get our severe flooding in the Lake District and areas of northwest Scotland where we've got high ground. This is called orographic rainfall, and this really helped this flood event to be, unfortunately, as damaging as it could be, with the combination of these mountains, the converging winds due to the kind of stalled frontal zone, that's the boundary, the temperature moisture boundary, and the upper level jet. And then the kind of final cherry on top, if you like, was the fact that after all that rainfall in this kind of region here, if you just keep an eye, you can see how the satellite, just the rain is constantly there. The kind of final piece was that the core of Helene moved up, and that itself brought a very, very a period of very heavy rain rates, which just ended up creating those incredibly high totals, like kind of 15 to 30 inches widely. And that's just in North Carolina. You can see Georgia saw as much as 15 inches. Florida saw also 15 inches. But it was really in the mountainous areas where that was an issue, because the rain just runs off the slopes. They're kind of impermeable. It runs into the rivers. The rivers are overwhelmed. They burst. There were instances of dams bursting in Tennessee. And that's really the result was this catastrophic flooding, which you can see here. The river was probably in its normal state runs through this region here. You can see completely filling the valley floors, and all these buildings unfortunately hit really badly. You can see similar thing here, and the worst impacts were seen in those kind of mountain valleys where you have entire roads and villages washed away, as you can see in this case. So that's kind of a meteorological analysis of Hurricane Helene and the catastrophic impacts it brought to parts of the USA. As I said, this is kind of a different video to usual, but I hope you found it kind of informative. And really, at this time, we should be kind of having our thoughts with the victims. It's a very awful event, and hoping they all have a speedy recovery, and that impacts from now on can be kind of reduced, and everyone can get back to how things were before. Anyway, thank you very much for watching, everyone, and have a great day. Bye-bye.